Welcome back to Geometry, new chapter, chapter 6, section 1 in this book. And today we are going to be talking about polygons. They sound fun to say like pollywogs, but polygons. Poly means many. Gons, sides. So polygons are figures with many sides. Now, remember when we did will it triangle? Kind of like Rhett and Link, will it taco? Will it polygon? Is it a polygon? Now the rule is the sides of a polygon have to be straight. They have to meet. You can't have gaps and no curved lines. And it can't have any crisscross in it. Alright, so let's see, is it a polygon? This one has a dent. Is it a polygon? Yes it is. It can have a dent. It doesn't matter. Dents are fine. All the sides are straight. That all meets up, that's a polygon. How about that one? Yep, that's a polygon. It might be a little curved, crooked, but it's just because I drew it bad. You can see it in your book and it looks good. That's a polygon. How about that one? It's got a gap. No, not a polygon. No gaps allowed. How about that one? Yes, it can have 5 sides. How about the classic piece of pizza shape? No, because it has a curved line. How about Black Widow's symbol? No, because it crisscrosses. No crisscrossing. Okay, now you can have convex or concave polygons. If it's convex, all of the pointy parts, called the vertex, plural vertices, go out. So all of them are poked out if it's convex. It's concave if any of them are poked in. It can be poked in more than one place. So this one is concave, that one and that one are convex. That one is convex, that one is concave, that one is convex, 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 convex. Okay, next idea. You can have equilateral, equiangular, or regular polygons. If it's equilateral, equa means equal, lateral means length of the sides. So this one has 4 equal sides, it's equilateral. But notice its angles are different. Doesn't matter, it's still equilateral. This one is equiangular. All 4 of these angles are the same, they're 90 degrees. The sides are not. So it's just equiangular. But this one is regular because all the angles are the same and all the sides are the same. So a square would be a regular polygon. All the angles would be all the same and all the sides would be the same. Okay, sometimes you make diagonals in a polygon. How you do that is you draw a line from a vertex to the other vertices. So those are diagonals. Now, we have a theorem. We couldn't have a chapter without one, right? The interior angles of a oh, I have to teach you something first. What is a quadrilateral? You might not know. Okay, so remember how you learned how to count 1, 2, 3, 4. And then maybe you learned in Spanish. Uno, dos, tres, cuatro, catorce. No, that's a U2 song. Okay, uno, dos, tres, cuatro. Well, and we have a way to count in polygons, okay? So the smallest polygon you can have is a triangle. So 3 is tri. 4, a 4-sided figure is quadrilateral. Sometimes in schools, like colleges, they'll have an area called the quad, and it's a 4-sided courtyard usually, so you might have heard that. 5 is pent, just like the Pentagon, you know, the big building in Washington. 6 is hex, like a hexagon. 7 is the one nobody knows. It's hept, H-E-P-T, so a heptagon. 8, octagon, oct. 9 is non, so a nonagon, that's fun to say. 10 is dec, a decagon. And then they did 12, dodecagon. So it's similar to if you've ever learned how to count in chemistry. While we're talking about dec, let's just get one of my little pet peeves out. You will hear people, all the educated people say that it was decimated. And what they mean is it was utterly destroyed. But that's not what decimate means. Decimate goes back to that dec, des. It means 1/10. it means 1/10 of it was destroyed. 90% is still good. They use that wrong all the time. Decimate does not mean utterly destroy. It means 10% destroyed. 90% just fine. All right, that was my little English rant. You know, I'm an English minor. Okay, you wouldn't believe it though, would you? Okay, so here's our theorem. In a quadrilateral, that means a four-sided figure like that one, or that one, or that one. In a quadrilateral, if you add up the four angles, it equals 360 degrees. Now, is this true for a pentagon? No. Hexagon? No. Octagon? No. Only quadrilaterals, if you add up their four angles, it's 360 degrees, which I kind of remember that because it's sort of like a whole circle. And it's like how we've already learned that if you add up the three angles of a triangle, it's 180. So now we've gotten another one. And we're going to learn about the others, but that's all for today. You'll just have to wait and come back and learn more about the angles of polygons. All right? Math is great. See you next time.